5. Kinetics. 5.1 Collision theory. Kinetics is the study of the factors that affect rates of chemical reactions. That is, how quickly they take place. There is a large variation in reaction rates. Popping a test tube full of hydrogen is over in a fraction of a second, whereas the complete rusting away of an iron nail could take several years. Reactions can be sped up or slowed down by changing the conditions. For a reaction to take place between two particles, they must collide with enough energy to break bonds. The collision must also take place between the parts of the molecule that are going to react together, so orientation also has a part to play. To get a lot of collisions, you need a lot of particles in a small volume. For the particles to have enough energy to break bonds, they need to be moving fast. So, for a reaction rate, you need plenty of rapidly moving particles in a small volume. Most collisions between molecules or other particles do not lead to reactions. They either do not have enough energy, or they are in the wrong orientation. The following factors will increase the rate of a reaction. Increasing the temperature. This increases the speed of the molecules, which in turn increases both their energy and the number of collisions. Increasing the concentration of a solution. If there are more particles present in a given volume, then collisions are more likely and the reaction rate would be faster. However, as a reaction proceeds, the reactants are used up and their concentration falls. So, in most reactions, the rate of a reaction drops as the reaction goes on. Increasing the pressure of a gas reaction. This is the same effect as increasing the concentration of a solution. There are more molecules or atoms in a given volume, so collisions are more likely. Increasing the surface area of a solid. The greater the total surface area of a solid, the more of its particles are available to collide with molecules in a gas or liquid. This means that breaking a solid lump into smaller pieces increases the rate of its reaction because there are more sites for a reaction. And finally, using a catalyst. A catalyst is a substance that can change the rate of a chemical reaction without being chemically changed itself. Now, only a very small proportion of collisions actually result in a reaction, as we've mentioned before. For a collision to result in a reaction, the molecules must have a certain minimum energy, enough to start breaking bonds. The minimum energy to start a reaction is called the activation energy and has the abbreviation EA. You can include the idea of activation energy on an enthalpy diagram that shows the course of a reaction. Figure 1 shows the reaction profile for an exothermic reaction with a large activation energy. This reaction will take place extremely slowly at room temperature because very few collisions will have sufficient energy to bring about a reaction. Figure 2 shows the reaction profile for an exothermic reaction with a small activation energy. This reaction will take place rapidly at room temperature because many collisions will have enough energy to bring about a reaction. The situation is a little like a ball on a hill. See figure 3. A small amount of energy is needed in figure 3a to set the ball rolling, whilst a large amount of energy is needed in figure 3b. The species that exist at the top of the curve of an enthalpy diagram is called a transition state or activated complex. Some bonds are in the process of being made and some bonds are in the process of being broken. Like the ball at the very top of a hill, it has extra energy and is very unstable. Endothermic reactions are those in which the products have more energy than the reactants. An endothermic reaction with activation energy EA is shown in figure 4. The transition state has been labelled. Notice that the activation energy is measured from the reactance to the top of the curve.